All right, here we go, guys. I titled these notes 36B, so you can add them to your AB stuff. These is just a second rendition, right? It's your first official BC notes, but we gotta. I'm just adding them to the tally. So I put some thought into this, and we were gonna go into the right into velocity, but I figured might as well just talk about parametric curves. So parametric curves, guys, it's not a big deal. Do you guys remember? Okay, let me take out a calculator really quick. Remember, like, let's say we wanted to graph like a parabola, y equals x squared. You can do that with a parametric, because remember, it depends on x and y. Oh, that's we're in polar here, so let me reset this. So watch. If you click on mode, you see how there's something that says parametric. So if I click on parametric, by the way, we never need to actually use it. I'm just trying to show you guys a review. And if I click on y equals, see how you have in terms of x and y? You can come in. You can come in, Zoe. Uh, and so let's see. I wanted to have y equals x squared. So what am I going to put here? T squared or something? Or so yeah. What I'm trying to do is this. So I'm trying to graph y equals x squared. So if x equals t, then I can say y equals t squared, and then that will graph. See if y equals x. So that's like saying y equals x squared. Do you guys see that or no? So see how it says x equals t up here? So imagine, so that t, I could just replace it with x, and then you would graph y equals x squared. So if I came over here and I drew x equals t, and then I come over here and I go t squared, that would graph. Like, check it out. Here's my window. That t min is 0. That t max is 2 pi. That's actually 2 pi. So it's going to graph just the positive version, just the quadrant 1. Look. See? Chop, how do I make it graph the 1 in quadrant 2? Well, that's a negative t values. So I would go, and I would just go negative. Let's go to negative pi over 2. Negative pi over 2. And now it's going to graph that part. Negative pi over 2 to 0. If I go negative 2 pi, I'll go negative 2 pi. Negative 2 pi t values. Boop. See? Cool, right? So all this is saying is that I just have some reference in terms of t. And then eventually, look what it says. If x and y are given as functions, x equals f of t, y equals g of t, over an interval of t values and set of points x, y equals blah, 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 defined by these equations as a parametric curve. These equations are parametric equations for the curve. So that's all it means, guys. You just have some variable, some t, and based off of what t value is, that's where your x and y. You know what I mean? Okay. It says, find the line tangent to the right-hand hyperbola branch defined parametrically by. So they're telling me that x equals secant tan and y equals tan t. The tangent line is still the same, guys. It's still y minus y1. Well, I guess I'll just say. For a tangent line, you still need a point and a slope. So I still need a point. Still need point. And I still need slope. Need dy dx. Dy dx literally means slope. Cool or not cool? So notice, they're nice to us. They give us a point. They didn't have to. They could have told us find the tangent line at pi over 4. And how did they get these values? If you plug in a pi over 4 into secant, secant of pi over 4 is square root of 2. Chop, how? Secant of pi over 4. Well, remember that secant is 1 over cosine of pi over 4. And so 1 over square root of 2 over 2 is 2 over square root of 2. So 2 square root of 2 over 2. Look, see how we got this? Sorry if I'm going too fast, but does that make sense? And so they didn't have to give us a point. Look, t of power. So how do I get the y value? Y equals tan of t. So tan of pi over 4. Well, that is 1. See? So that's how we got the x value of square root of 2 and the y value of 1. Yay or nay? They're being nice. They're being nice. Did I have to do any of that? No. But just in case, if they say find the tangent line at t equals some value, I need a point and I need a slope. Okay, you guys ready to get my slope? All right, so here it is. I'm going to say this. My slope, dy dx, I'm going to have to get dy dt. And I'm going to divide it by dx dt. See, when I do that, do you see how the dt's cancel out? So there it is. So dy dx is dy dt divided by dx dt. So here it is, guys. Y equals tan t. So dy dt is equal to, what's the derivative of tan? Secant squared t, because I'm taking derivative with respect to t. That makes sense? Okay. And then I'm going to write dx dt. So I'm going to take the derivative of secant t. So what's the derivative of secant t? Secant t tan t. Secant t tan t. All right, keep going.
How'd that change? Oh, it's dx dt?
It's dx dt, yeah.
Oh, I'm sorry, I forgot that. He's referencing the points at the top.
What happened, Montalvo? Montanes? Sorry. I haven't done anything yet, guys. What's up? Huh?
Is dy dt over dx dt and the dt's cancel out?
Yes. Well, that's what dy dx is. See, dy dt over dx dt, the dt's cancel out. I haven't done it yet. I haven't plugged it in. So here it is, dy dt. So I'm gonna write dy dx. And okay. Notice that I still have t's in there, guys. So write this, dy dx evaluated at t equals pi over 4 equals, and you're going to put the dy dt first, secant squared at pi over 4 over secant, I guess we could have canceled out one of them, secant pi over 4, tan pi over 4. Do you want to cancel out one of them? All right, here we go. One of those with one of those. Okay. All right. What is secant of pi over 4? You did it earlier. 1 over square root of 2, which is the same thing as just square root of 2. So I'm going to write square root of 2 divided by, what is tan of pi over 4? 1. Let me make sure that I'm not messing anything up. All right. I got it, guys. So here's my, tangent line when t equals pi over 4 is y minus 1 equals square root of 2 parenthesis x minus square root of 2. How do we feel? Nothing crazy, right? Okay. All right. You guys ready? All right. Here we go. This is coming from delta. I believe it's coming from delta. A curve is defined by the parametric equations x of t equals negative 7 sine 8t and y of t equals negative 6t cubed plus minus 2t squared plus 10. Find dy dx. So tell me, I got to do what? I got to find... I gotta get a point. Actually, a curve is defined parametrically... No, and this one I just want to dy dx. So all I got to do is go dy dt divided by dx dt.
Do we have to do that on each problem?
If it's one of these, yes. You're gonna have t's, guys. You're gonna have t's. So here it is. Ready? Okay, ask me.
Like we have to put that notation?
Yes, you have to put that notation. Because see how the dt's cancel out, and that's your dy dx. You're gonna have t's. You are gonna have t's. All right, here we go. I'm gonna come over here. I'm gonna go dx dt, and I'm gonna take the derivative of this. What's the derivative of negative 7 sine 8t? Yep. Negative 56 cosine 8t, or negative 7 cosine 8t times 8. So you get the negative 56. What's the derivative? So I'm going to write dy dt of negative 6. Oh, I'm already writing negative 6. What's the derivative of this guy right here? Yep. So here it is. So I'm going to write dy dx is equal to, and I'm going to put this first, negative 18 t squared minus 4t divided by negative 56 cosine 8t. And there it is. Those t's don't cancel out. That's your dy dx in terms of t. What do you guys think? All right. You see these things? They're called chevrons, like the gas station. but they're on the side instead of upright. They're called chevrons. You use chevrons whenever we have vectors. So what they're telling us here is that I have some function and that it's a vector where x of t is this and y of t is that. What is the value of f prime prime of t? Okay, we're going to go slow. So first and foremost, f prime prime of t is a vector. All right, so I'm going to write f prime of t. We got to get to the second derivative, we got to do the first. So the first derivative, chevron. What's the derivative of 5 sine negative 4t? Negative 20 cosine negative 4t, comma, what's the derivative of negative 3 sine 2t? Okay, there it is. Now let's keep going. Let's do another derivative. F prime prime, chevron. What's the derivative of negative 20 cosine negative 4t? Well, the derivative of cosine is negative, so it's going to be positive, but then I'm going to multiply by negative 4. So I think it is negative 80. Do you guys see what's going on? Yeah, we can show it. We can show it. Check it out. We can show it. We can go positive 20 sine of negative 4t times negative 4. See? So there it is. It's going to be going back to negative. Comma, negative or positive, the derivative of 6 cosine t is going to be a positive 6 sine 2t times 2. So, oh yeah, well, I'm about to because I multiplied by 2. So, chevron, negative 80 sine negative 4t, comma, 12 sine 2t. And there it is. That's it. It didn't ask us to evaluate it at a specific value. Does that make sense? Okay, let's keep going. Cool job. But what if they ask me to take a derivative? Second, what does this mean? Second derivative. Second der. What if they want the second derivative in terms of t? Okay, well, let's do it. First, you got to find the first derivative. So the first derivative, I'm going to write dy dx equals dy dt divided by dx dt. So let's see what dy dt is. Dy dt is going to be 3e to the 3t over 6e to the 2t. 3 goes into 6 how many times? Twice. Does this look fun, 8th graders and holiday? It's actually pretty fun. It's not that bad. It really isn't. All right. Are we still okay? All right. So here it is, guys. You see this right here? I'm going to take the derivative of that, but I'm taking it. Okay, look what this says. I have to take it with respect to x. But do you see any x's in there? No. So when I take the derivative, so what I'm going to say is this. I'm going to take the derivative again, d dx of dy dx. So I'm going to go d dx of e to the 3t over 2e to the t. What rule do I got to use? Say chain. Quotient with chain. That's not an x, that's a t. So I'm going to go bottom. Don't worry. Okay. So guys, look, I'm taking, that's not an x, that's a t. So really what you're doing is this. You're doing this. You're going dt dx. When you do, what's up? The 2's still there. The 2's still there. I just missed it. Let's see, did I fix all my errors? You know what, guys? I forgot we could use. Why didn't you guys tell me? We can make life so much easier. All right, hold on. Let me see. What am I going to erase? Okay, let's go back. We can make life so much easier. See, I haven't done this in a while, so good thing that we're doing this so you guys can see. This is correct still. Bless you, cube. Guys, law of chains. Law of change. Law of sign. Law of exponents. I have e to the 3t in the top. I have e to the 2t in the bottom.
Oh, I was going to mention that earlier, but I didn't know if that was on purpose.
No, 1 over 2 e. 3t minus 2t is just 1t.
Oh, my bad.
Right? Whenever you're dividing, you can subtract. Yeah, so side note, as long as the bases are the same, they are, e and e. X to the m over x to the n, that's x to the m minus n. See? So e to the 3t, e to the 2t, 3t minus 2t is just 1t. Are we still okay? Okay, so yeah, look, now this looks better. So now look, d dx of 1/2 e to the t. That's not an x, that's a t. So that the derivative of that is itself 1/2 e to the t times dt dx, chain rule. Because I took the derivative with respect to what? X. Is that an x? No, it's a t. Do you guys see that? Okay, relax. Chop. I don't know what dt dx is. Yes, you do. Isn't this dx dt 6e to the 2t? Okay, I'll come over here. Sorry, guys. Look, dx dt is equal to 6e to the 2t. Yay or nay? So that means dt dx has to be equal to 1 over 6e to the 2t. See, this is just 6e to the dt over 1. dx dt. Do you guys see that or no? It's like a little hack. So this is going to be 1/2 e to the t times 1 over 6e to the 2t. So let's see what I have. E to the t in the top. 6 times 2 is 12. E to the 2t. We still okay, guys? This e to the t cancels out with one of those. E to the t. So bam. So 1 over 12e to the t. That's your second derivative. Do you see how we did it? Okay. Did you guys think that was tough? You just kind of got to just slow down a little bit, right? You guys ready? I thought I was going to take up more space. I know, that's why I put all that space down there. Okay, a curve in the xy plane is defined by vector values. So they didn't put these are just a coordinate right now. But it's still a vector. So when you take derivative, it's still a vector. But notice it says what is the second derivative of this? So this one is not going to be a vector because you're not finding f prime prime. You're finding the second derivative of this. So you're finding dy dx, and then you're taking the second derivative of that. So it's not going to be a vector. This one, you don't have chevrons. Yeah, they didn't. If we would have said f prime of x and we would have kept it like that with the chevrons, it would have been a vector. But since we want to see how it says d second, so this means the second derivative of dy dx, right? Or the second derivative of my function. So I'm going to find my dy dx first. And once I do that, it's no longer a vector. It's just dy, it's just a slope of a tangent. Yeah, if you would have said if this would have said find f prime prime, then it would have been a vector. Because you would have left it in component form with the x with the x, the y with the y. Like, well, this is a coordinate. The second derivative is no longer a coordinate, right? The second derivative is the acceleration. Okay, yeah, we need more experience.
I might be asking too much right now.
Yeah. Right now, so we're not, see, because we haven't even done particle motion yet. So right now, this right here is not a vector because we're just finding dy dx, which is just slope of a line, and then we're taking another derivative. So I guess you can say it's the rate of change of the rate of change of whatever, but it is not at the moment acceleration or whatever, because we're not. This is not a particle or anything just yet.
So is a vector velocity?
A vector is like like velocity and acceleration and all that good stuff. Those are all vectors. But right, this is not an acceleration because yeah,
Vector is just like a specific slope.
this dy dx is the slope of this curve, and the second derivative is telling you the rate of change of this curve. But it's not telling you how fast this curve is moving in the x and y direction, because dx dt is how fast it's moving in the x direction. Dy dt is how fast it's moving up and down. But we're not even doing that just yet. We're just doing parametric curves. We're just doing okay. We're okay. Okay. Yeah. No, it can be tough, guys. It can be tough. Okay. Ready? Here we go. Dx dt equals -3, and then what's the derivative of ln of -2t? 1 over -2t times -2. So dx dt, sorry that looks like dx dx. There we go. Equals, let's see, those -2's cancel out. -3 over t. I don't see any issue right now. I think we're okay. Are we okay? All right. dy dt equals, what's the derivative of -5 sine -5t? 25 cosine of -5t, right? Okay, so here we go. I need dy dx. Dy dx is equal to dy dt. So put the notation, guys. Divided by dx dt. So always use that notation. So dy dt 25 cosine of -5t divided by -3 over t. We're still okay? Keep, change, flip. Let's see. -25t cosine of -5t over 3. I guess if you don't like that, you can write it like this, which I am because I don't like it. Dy dx, I'm going to write it as -25 over 3 t cosine of -5t. That way I don't have a fraction. Are we okay, guys? All right, so here's what I'm going to do. Semicolon. I'm going to take a derivative with respect to what letter? X, with respect to x, d dx. I'm taking a derivative of dy dx. See, that's my second derivative. So d dx of this guy, -25 over 3 t cosine of -5t. Have I freaked anyone out? Hey, did you put creamer in this?
Yeah.
Okay. And you made it strong.
I'm sorry.
No, you're good. You're good. All right, here we go. I'm taking the derivative of this. That says x, and those are t's. So I have to do, it looks like I have to do what rule? Yep, chain, but it looks like it's a product. So first, -25 over 3 t times the derivative of the second, negative cosine -5t times -5. So it's going to be, 5 sine -5t. Let me know if I make mistakes. Plus second cosine -5t times the root of the first, -25 over 3. Is everything okay so far? And then put a giant parenthesis on the outside. Okay.
We're taking it with respect to x, right? So
Exactly.
So would it be
dt dx. Chain rule. On the outside, put dt dx. Don't forget it.
Wait, it's on outside the whole.
Well, okay, I'm skipping a step. I could have said first times root of the second, and when you take the root of the second, you write dt dx here, plus second times root of the first, but I could have written dt dx there, but I'm just factoring it out. That way it can look cleaner. Does that make sense, guys? You can tell me no if it doesn't.
That makes sense. I didn't notice on the first one.
Yeah. So it's because we're in BC now. We're with the big dogs. So check it out. Look, first times root of the second. I could have written right here. That's not a T. Stop. That's not an X. That's a T. So I could have written dt dx right here. Plus second root of the first. Stop. That's not a T. Put dt dx right there. I could have done that. But look, there's a dt dx right here. There's a dt dx right there. Factor it out. There it is. Because we're with the big dogs now. So, do you see that? Are we good? Okay, so here it is. Guys, we're almost done. We're almost done. So here it is. 25 times 5. So I see negative 125. Now, let me know because I make mistakes all the time. Is that a 3 down there? Sine of negative 5t plus, and I guess, yeah, I'm so, minus t minus 25 over 3 cosine negative 5t. I don't think I have issues right now. I think we're good, right? Are we still good? And dx dt or dt dx, it's a reciprocal of dx dt. So this one right here, there's my dx dt. So that means dt dx is equal to negative t over 3. Later, miss. Later, miss. Does that make sense, guys? Okay, so here it is. So I'm going to multiply this by negative t over 3. When I do that, here's my final answer. So, second derivative, dx squared is equal to, negative times a negative is a positive, so I'm going to see 125 over 9 t squared sine of negative 5t plus 25 over 9 t cosine of negative 5t. And I believe that is it. Oof. Hey, you guys want to BC? Oh, well, it's not bad. It's not bad. It's a like a frame of mind, you know? Yes. dx dt was negative 3 over t, so dt dx is negative t over 3. I just flip it, right? What's up?
Do you know where Mia's calculator is? She told me to get it.
I don't see it. It's a red one. I don't see it. Is it that one? No, Mia's is a red one. I don't see it. Color. Oh, look, her little sister's right here.
It's not Mila, Mia.
Oh, then it's a white one. It's that one. Has to be that one. Oh, is that it, guys? It's probably hers.